Okay, in this example, we're going to graph an ellipse. And so we're given here an equation for an ellipse. And in addition to sketching the graph of this equation, we also want to identify some of the major features of the ellipse, such as the foci, also called the foci of the ellipse, the vertices of the ellipse. So these are the extremal points on the ellipse, the elliptical curve, and then the lengths of the so-called major and minor axes for the ellipse. So we know that the graph of this equation is going to be an ellipse centered at the origin because this equation very clearly fits the form for an ellipse centered at the origin. Remember, when you have an equation of the form x squared over a quantity squared plus y squared over a quantity squared equal 1, then the graph of such an equation is going to be an ellipse centered at the origin. Now, the reason that we're identifying 9 as a squared and 4 as b squared rather than vice versa is because, remember, for an ellipse, a squared has to be always bigger than b squared because a must be bigger than b. And then also recall this important equation, which allows you to find the location of the foci of the ellipse. All right, so because a squared is equal to 9, of course, this clearly implies that a is going to be either plus or minus 3. And since x squared is divided by a squared, that means that the x-intercepts are going to be plus or minus 3. And then since b squared is equal to 4, that means that b is equal to plus or minus 2. And so that tells us that the y-intercepts of the ellipse are going to be at plus or minus 2. And then because c squared is equal to a squared minus b squared, we can easily here calculate the value for c squared. So that's going to be 9 minus 4. So that tells us then that c is going to be plus or minus the square root of 5. And then those two numbers tell us the location of the foci, or the foci of the ellipse. So the x-intercepts of this ellipse are going to be at plus or minus 3. And now the reason the x-intercepts are at plus or minus 3 is because, again, the quantity that divides into x squared in the equation for the ellipse, that always indicates the location of the x-intercepts. So since we had x squared was divided by a squared, and we recognize here that a squared was plus or minus 3, that means that the x-intercepts for the ellipse, one of them is going to be located at 3, and then the other one will be located at minus 3. Symmetric around the origin, of course, because the center of this ellipse will be at the origin. And then the y-intercepts will be at plus or minus b. That's plus or minus 2. And again, that's because y squared was divided by b squared in the equation for the ellipse. And so our y-intercepts would be at plus or minus 2 on the y-axis on the graph. And that already there is enough to allow us to draw a pretty decent graph of this ellipse. If I can draw a nice ellipse through these 4 intercepts. Yeah, not too bad. Okay, wobbled a little bit there. Let me erase that and try that last part of that curve again to make that look a little bit nicer. Yeah, well, that's only a little bit better. So there's the graph for our ellipse. The major axis now is going to be along the x-axis. And that's called the major axis because that's the it's between these two vertices of the ellipse, plus and minus 3 on the x-axis. That's the longer distance, so that's the major axis. And then the minor axis would be between these two vertices of the ellipse, the two y-intercepts. So the minor axis is on the y-axis. And now the foci are going to be located on the major axis. The foci are always located along the major axis. And the value for C gives us the location of the foci. So since square root of 5 is about 2.2, we know the two foci are going to be located at approximately plus or minus 2.2 on the x-axis. So about right there and about right there for the location of the two foci are also called foci. So one of our vertices is here at 3, 0, one of the x-intercepts. The other vertex is at minus 3, 0, the second x-intercept. One vertex is up here at this y-intercept at 0 and 2. And then another vertex at the second y-intercept, 0 and minus 2. And then the two foci here are located again along the major axis. So one is at square root of 5 and 0, and then another focus here at minus square root of 5 and 0. So it's fairly easy to graph an ellipse that's centered at the origin. All you have to do is identify these values, a squared, b squared, and c squared, which of course will allow you to deduce what the values for a, b, and c are. Those will tell you what the x and y intercepts are, and then where the two foci are located. And with that information, very easy to draw the graph.